Welcome to a demonstration of the new MechNet Incorporated Wind Tunnel Recorded Data Laboratory. What we have done at MechNet is record the airfoil data from a GDJ Incorporated Flowtech 1440 research grade quality wind tunnel. GDJ has been designing and building wind tunnels for the top four-year universities, research institutions, and calibration labs for the past 25 years. The data from the Flowtech wind tunnel is extremely accurate. This allows the students to compute the mathematical formulas from the data taken from the wind tunnel and achieve accurate results. Their results can be compared to the published data for the airfoils. MechNet has also created a complete blended learning media-rich set of lessons for aeronautics. The lessons use a combination of professionally narrated PowerPoint slides, animations, and videos to accomplish teaching everything from the properties of air to the coefficient of lift of the airfoil. For more on this, see our demo for the lessons. By recording the data from a series of NACA airfoils in a research-grade wind tunnel, MechNet has been able to create a software program that allows the students to accomplish laboratory experiments in the exact same way as if the wind tunnel were in their school, but at a substantially lower cost. One very important fact to keep in mind is that this is real data and video taken from an airfoil mounted in an actual wind tunnel. This is not a computer-generated CFD program of what we think the data should be. This is the real stuff. We have accomplished this by taking advantage of the power of National Instruments LabVIEW software and data acquisition hardware, along with the expertise and skills of the team at Viewpoint Systems of Rochester, New York, to create the program. Now let's move on to the operation of the actual wind tunnel recorded data program. What we have is a LabVIEW screen with a combination of controls to control the wind tunnel and data displays to illustrate the lift to the airfoils, along with a video display to see how the shape of the airfoil affects the airflow around the airfoil. Starting on the left-hand side of the screen, we have a slide bar to control the speed of the motor, which will increase or decrease the speed of the air in the test section of the wind tunnel. The student can view the velocity of the air in the test section by the bar graph next to the slider. Above the velocity bar graph is the airfoil angle of attack control. This allows us to control the angle of attack of the airfoil in the wind tunnel. As you can see, this program is completely interactive. The student is really controlling the wind tunnel, not just watching something happen. Let's take a look here. By increasing the angle of attack of the airfoil, the student, by viewing the video, can see the stall begin to propagate up the surface of the airfoil. Here we see the tufts moving on the rear of the airfoil. Now they're more violent, more tufts are moving. Here the rear of the airfoil is completely installed, but the front's still attached. We're still seeing data here, and now the airfoil is in complete stall. Now we move on to the display tabs. Here the student can select which airfoil they want to test from 3 different NACA airfoils. We have a NACA 0015, a NACA 2415, and a NACA 4415 airfoil. They can also select how the data is displayed by choosing upper surface pressure, upper surface velocity, lower surface pressure, or lower surface velocity. Here they can change the video display. What we see here is the airfoil with arrows. This program will change the length of the arrow based on the data taken from that area of the surface of the airfoil. As you can see, as we increase the angle of attack of the airfoil or velocity, the arrows will get longer. Or if we decrease the velocity, the arrows will get shorter. This is a good place to view the profile of the three different NACA airfoils. First, this is the 0.15, which is a symmetrical airfoil that has no camber. The shape is the same on the upper and lower surface. Next we have the 2415, which is a trainer airfoil. There has some camber on the upper surface. And finally we have the NACA 4415, which is a very high camber airfoil. Lots of camber on the upper surface and lots of lift, but also lots of drag. Next is the video selector. Here the student can choose between the upper surface video, the lower surface video, or a combination of the two. By changing the angle of attack of the airfoil, it will change which surface they're looking at. When they have a positive angle of attack, they will see the upper surface, and a negative angle of attack, they will see the lower surface. Now we move on to the top of the screen. Here we see a toggle switch which will change the data display from the English system to the metric system. This will change all of the values in the screen from, say, feet per second to meters per second for all the different displays. Next is the sound selector. When you select this, the student can hear the sound of the wind tunnel during the test. On the far right is a box which shows all of the data taken at the test of the wind tunnel. This will include the barometric pressure, the humidity, and temperature of the room during the test. Underneath the video screen is our display boxes, which show the airfoil angle of attack, the basic lift of the airfoil. This helps the students to see the actual lift of the airfoil during the test, and also the coefficient of lift of the airfoil. Next is a selector, which allows the students to copy the display data to an Excel spreadsheet at any time during the test. From this data, the students can do their own lift calculations of the... But wait, there's more. Since we have taken the data from three different airfoils, why not let the students compare the data from all three airfoils at the same time? Folks, you could not even do this if you owned your own wind tunnel. By clicking the 6 airfoil tab at the top of the screen, now you can see the data displayed in 6 different screens. A good illustration of this is comparing the zero lift data of the airfoils at different angles of attack. Due to the camber or shape of the airfoil, the zero lift will happen at different angles of attack. We can see at zero angle of attack that the 0.15 has no lift. Since there is no camber to the airfoil, at zero lift it will have no lift. At -3 degrees, the 2415 will show no lift. Now here's a good comparison. Let's look at the lift of the 4415 and the lift negative on the 0.15. Finally, at -5 degrees, the 4415 will have no lift. This allows the students to easily see in real time how the data from the three different airfoils will be affected and will change. The student can design their own data display and choose what they want in the various screens depending on what they want to see happen on the surface of the airfoil. And now, just when you thought this could not possibly get any better, what do we say? But wait, there is still more. Maybe you have noticed at the top of the screen there is a box marked Flap ice. Well, we have saved the best for last. This allows the students to view how the lift and stall characteristics of the airfoil are changed with a flap at 4 different angles. Here they can see the data video from a 10 degree, 20 degree, 30 degree, and 45 degree flap. And see how the flap affects the lift and stall of the airfoil at the various degrees. The flaps are used on the aircraft for both takeoff and landing of the airplane. We have also installed a 3D printed ice shape to the leading edge of the airfoil for the students to see what a pilot would encounter flying into icing conditions. We have installed both horn ice and clear ice to the leading edge of the airfoil. The students can see how this affects the lift of the airfoil at various angles of attack and air speeds. Thank you for viewing this demo. Next, look for a roller coaster, then a single cylinder engine.